URL of the Jupyter notebook that we'll be using. I'm gonna share my screen as well. And I'm gonna be going through that same notebook. Please feel free to download a version locally and run it locally. It doesn't require much. All the libraries that we're going to be using, as I go through them, I'll show you how to install them. Share my screen. Hey, what? This is denied. Can you try again? I just shared it with everyone. I just authorized everyone. Anyone with a link can done. Can you refresh? Okay. Notebook. You're still having a hard time? Link. Anyone with the link should be able to view it. Can you download it? So file, download as Jupyter Notebook, as an AppIO1B. That's all you need. It's just download it and you can run it locally on your Jupyter installation. Or you can download it and upload it back to Colab if you want to run it on Colab. So the reason I don't give access to edit is because I don't want people to change it locally for everyone else.
Excuse me, I'm just looking for this
Okay,
file.
so
Notebook. I don't
good
see
to
it.
go. If you have any questions regarding the notebook, or if you have any questions as we're going through the notebook, please feel free to ask. I think Shivani is going to keep an eye on the chat. Thank you. I appreciate it. I welcome questions during the presentation. I really enjoy interactive presentations. And so yeah, if you have any questions, please feel free to ask. So prompt engineering. It's a word that has been used a lot over the past 3 or 4 years, and it's a word that is very poorly defined. You ask 3 people that work as prompt engineers, and they'll definitely give you different definitions of what their job consists of. No one has an exact definition of what prompt engineering. What people typically agree on is that prompt engineering is about communicating effectively with language models to achieve desired outcomes. So obviously we use language models to achieve an outcome, to get a response. And so how do you formulate your question in a way that leads to an answer that is relevant to you, makes sense, usable, and so on? So the objective here is that we can always modify the outcome, or we can modify the way the response is provided by fine-tuning the model, by training that model, by changing the weights of the model. But we don't want to do that. So we're not going to train the model. We're not going to fine-tune it. We're going to give it an input, and we're going to formulate that output, or write that the input that in a way that gives us the output that is usable to us. This is not really important at all if you're working with a language model in the context of a chatbot, or using it as a chatbot. You're sending questions, getting answers, and so on in an interactive way. Where this is really helpful is when you're using a language model in a programmatic way, meaning that you're sending a question to a language model and you're taking the output that it gives you in order to use it programmatically in your script, or in order to put the outcome in a database, or in order to take that output and feed it into another model somewhere else. So prompt engineering typically consists of writing prompts or writing questions to a language model in a way that forces it to give you an answer that adheres to some requirements. Typically, these are programmatic requirements. Okay. So one thing I have to emphasize is that prompt engineering, I don't know why the word engineering is there, but it is not a science. It is an empirical activity that varies among models. So you're going to write a prompt. You can write a prompt for a language model that works really well for, let's say, ChatGPT 4.0, but does not work very well for ChatGPT 0.1, or does not work very well for Claude or for Llama. And even within the same model, prompts that you may write might not work if there's a minor change to the model. So even minor versions can break the prompts. So prompt engineering is a lot about heuristics, trial and error, experimentation, and very, very little about fixed algorithms. So we have some sort of intuition on how to write a prompt that makes sense, that forces the model to give me an output in a specific way. But it is really about heuristics and experimentation. It has come a long way, and the newer models are really good at adhering to formats. And there are a lot of new techniques and new models that have been specifically trained to be used programmatically. But still, there are no guarantees that your prompts are going to work across versions or even across days, right? There's a sort of a probabilistic aspect to how an LLM answers. And a prompt that works really well now may not necessarily work very well in 3 hours or 6 hours. So it's super important to benchmark and test constantly your prompts. So all the prompts that are currently deployed in a commercial product, those companies do a really good job at keeping 24/7 track of what the prompt is doing, what people are asking, how it's responding. So because there's this probabilistic aspect of the language model that we can't control. So the first thing I would like to cover is this concept that language models, despite the fact that we interact with them using text, what language models take as input are tokens. Tokens are numbers, they're encodings. Essentially, language models or machine learning models in general don't understand text and have to convert that text into tokens. And a token, you can think of a token as a word or a subword. I'm going to explain this concept in a second, but it's just a unit of text that gets encoded and that gets passed onto a model for the model to take it as input and generate its outputs. So for instance, if I take the following, hello world, this is my text input. Well, it turns out that this text input is going to be broken down into 4 tokens, hello, and a comma, and a world, and an exclamation point. And this is going to have 4 tokens that are going to be passed on as input to the model. If I'm giving it something like, I'm loving this workshop, I is a token, apostrophe, you can't see it here, but there's an apostrophe M is a token, loving this workshop is so you see that I am got split in 2. And in all 3 examples that I gave you here, all 3 of them have words, full words, so complete words, but it could be that some words get split into subwords. So there's no guarantee that a word will be an input to the model. So there's a library, it's called TickToken, and this is the library that OpenAI uses in order to convert text into tokens. And every model has its own sort of flavor of TickToken and how it uses it to convert the text into tokens. For instance, GPT-4 and GPT 3.5, they use this CL100K base. Codex models, they use something called P50K base. But essentially, they do exactly what I just covered. Take a sentence, break it into words or subwords, and convert those subwords or words into numbers. Here's how TickToken gets used. We're not going to use TickToken. I'm just giving you an intuition of what the language model takes as input, and I'm going to explain why we need to understand that. So I'm going to create this instance of TickToken, and I'm going to say, hey, give me the encoding that is used with GPT-4. So it gives me this variable, and this variable can then encode some text as input. So for example, if I take this text, prompt engineering is a skill, and I encode it, and I print the count of tokens that I have, the list of the words that this sentence got split into, and I print the tokens itself, it says that this list got split into 6 tokens, that are token number 55715, 15009, and so on and so forth. So I have this here generated 6 tokens, 1, 2, 3, 4, 5, and the dot is a 6. So just like it has this encode, it has something that's called decode. And we can use this function that's called decode, and I say decode a list of tokens. In this case, I'm giving it a list of a single element, and this element is apostrophe M. I can give it another element and say decode 13. 13 is a period. So these are numbers that are hard-coded in that encoder and decoder, and it knows how to take a word or a subword and encode it as a number, or take a number and decode it back into a subword. So I can give it a list of elements, 40 to 846 to 1955, and so on and so forth, and say decode this, and it says, I'm loving this workshop, right? So the reason we need to understand what tokens are is, let me just try something here very quickly. I'm going to try doing this, run this, and say tick token dot encode commercialization. And oops, tick token encoding. Sorry about that. I think I didn't import something in here. Oops, oh, I'm running in the wrong model. I'm gonna run in this one instead. Sorry about that. So I'm gonna do a lot of demos, some on the fly. So please bear with me if there are any issues. Commercialization. So code. So you see, for example, this commercialization got encoded into 2 words, 847707 and 2065. Let's see what these words are. Let's take this and say decode this for me. So decode the first one and then the second one. The first one is commercial, and the next one is ization. Oops. And then the next one is ization. So you see, in this case, this commercialization, one word got broken down into tokens. So the reason we need to understand this is that when we write a prompt, there's a cost associated with it. What we give as input to the language model is a series of tokens, and we pay by the tokens that we give the language model, and we pay by the token that the language model gives us back. So the prompt tokens is what we give the language model. These are the tokens that we pass as input to the model. And the completion tokens are the tokens that the model gives us back in a response. So the total number of tokens is the prompt tokens, what we give the model, and what the model gives us back is the completion tokens. And it turns out that the cost associated with these models and with these types of tokens is not the same. So typically it's cheaper. We pay less money for giving the model tokens, and we pay more money for the tokens that the model gives us back. So for instance, GPT-4o mini, which is a smaller version of the 4o, an inexpensive version, we pay 15 cents for 1 million input tokens, and we pay 4 times more, or 60 cents, for 1 million output tokens. So this is super important to understand and keep in mind that anything that you give the model, you have to pay for it in a programmatic way when you do prompt engineering, and everything that the model gives you back, you have to pay for it. And typically more than what you pay for the inputs. This is also very important to understand because the context, how much information a model can digest, which is called the input context, is limited. Over the past couple of years, it has grown exponentially, or not exponentially, but it has grown a lot. And now we can have context of about 8,000 to 16,000 in the commercial version of ChatGPT 4o. But still, this is not enough if you're doing prompt engineering on collections of documents. You're giving it, PDFs, and you want to extract information such as, financial statements, or you want to give it sort of medical records and extract information about health information from the patients and so on and so forth. So two things to keep in mind is when you're doing prompt engineering, you're paying for the tokens, but you're also constrained by the size of the prompt, the context that you're working with. So you cannot just, write very, very long, lengthy prompts that describe exactly what you want to do. You have to be very judicious and very careful and deliberate in describing the prompts that you want to do. So turns out that, as I said, the most relevant and important way that we use prompt engineering is to programmatically do something with language models. In order to use, for example, ChatGPT, every big language model out there has a library, a Python library that allows you to programmatically and interact with that language model. Typically, you're going to have some sort of API key, you think of it as a password that you send the language model to show that you're authenticated and you're allowed to interact with it. And all interactions typically that happens in a programmatic way, you pay tokens in and out. Unlike, for example, subscriptions or the free tier, when you're programmatically interacting with ChatGPT or Claude or Meta or commercial service, you have to pay some fees. So I'm showing you some code here. We're not going to use this code, but just to give you an intuition. So this code here creates a client that is going to allow us to communicate with ChatGPT so we can give it prompts and it can give us information back. So there's a function called getCompletion. This function takes as input a prompt, some text, some question. It also takes the model that we want to use. For the whole purpose of this workshop, we're going to use GPT-4o mini. And takes essentially the model and sends this client a set of messages. The minimum number of messages that we need to set is a message from the user. The same thing that you type in a prompt when you're communicating with ChatGPT on the web. The user is typing some information and we're getting the results back. Here, we're sending it programmatically. So we say the role is a user, meaning this message is from the user. And the content is the prompt that gets passed as input to my function. So this is the message that I'm sending. So what this client needs to send ChatGPT is client.chat.completion. So meaning, hey, complete this or answer this for me using this model, using this messages that the user sent, and using this parameter called temperature. I'm going to talk about it a little bit later. And it returns a response. So if I run this code, here I give the explanation of what these things are doing if you want to read through it later, but essentially it's just what I described. So what I can do is I can send this function, I can get completion. What is the capital of Canada? So question that I'm sending the model and run this function. It takes a few seconds to execute. It sends the query to ChatGPT programmatically, and it returns this big complex object that has a bunch of information, including this ID, the interaction. Every interaction that we have with ChatGPT has a unique identifier. It has the reason why it stopped. And the reason we include why it stopped is to let the user know whether it stopped because it finished the answer or because it ran out of tokens, right? So sometimes if the answer is very, very, very long, you can run into the situation where the model stopped solely because it ran out of token and it couldn't complete. It has a bunch of other information, including the message back, which is it's a chat completion message. And it says the capital of Canada is Ottawa. And it has the number of tokens that it used. So I'm not gonna worry about this too much. I'm gonna show you that we can take this completion, this object, and look at the various components of it and extract the response by simply saying components, give me the first completion. In this case, there's only one completion, but you can ask the model to give you multiple answers, right? Different answers are generated differently. Give me the message and give me the content of that message. And it says the capital of Canada is Ottawa. So I'm going to modify this function so that it doesn't return this big, complex, hairy object that we don't care about. I want it to return only the answer. Response choices 0, get message content. So if I rerun this function now and I say this code here, and I say I rerun this function and I do something like the following. it says the capital of Canada is Ottawa. So it sent the message to ChatGPT and got me the answer back. Right. Good so far. Any questions? Are you okay with me doing this interactively? Are you getting seasick, dizzy, me going up and down? Okay, perfect. Okay, so what we just did is we provided a question to ChatGPT. And programmatically speaking, this is the worst thing that you can do because you have zero control over what the model or how the model is going to answer back. And so typically it's called zero-shot prompting. Zero-shot prompting is that you're asking the model to take a shot at providing you with an answer when you're giving it zero information about what you want that answer to look like. It is the simplest form of prompting. It essentially gives a direct question without any examples, and the model attempts to answer based on general training, how it was trained to answer. This is sort of okay if you want to, for example, take input from a user, compute some answer for it, and send the answer back to the user. It's absolutely fine. There is a simple trick. Well, actually, I'm going to talk about it in a second. So let's run this and see what it does. So this is get completion for a prompt. What is the most populated city in Hawaii? And we ask it for an answer. So this is a new line, and we ask it for an answer. I don't have to use that answer here. So this is what I'm doing. I say, what is the most populated city in Hawaii? And it says the most populated city in Hawaii is Honolulu, and it gives me this lengthy, long answer. So imagine that I am only interested in the name of the city because I want to take that name of the city and I want to, find the population, and I want to find, I don't know, flights to that population, to that city. So all of this information, the most populated city in Hawaii is Honolulu. It's located on the island of Oahu. This is useless. All I want is Honolulu, the answer that says Honolulu, period. Well, how can we do this? How can we say, hey, model, don't give me that lengthy answer. Give me just the name of the city. Because that's only what I'm interested in, and I need to take that city and put it in a database, or I need to send it to another model, or I need to query some weather forecast or something with it. So one way you can do that is by literally doing that, is by describing in complete detail the desired output. So exactly what I said. You can, add more details, say, hey, I don't care about a long answer. Don't give me any details. Just give me the name of the city. And this works really well for simple examples, like the ones we're working with here, but requires much more text to describe how to extract items, let's say purchased, and quantities from, let's say, a receipt, an example that is a lot more complex. The other one is by illustrating the desired output using examples that we pass as part of the prompt. So here is the first, the elaborate prompt that I was talking about. So here's what I'm saying. What is the most populated city in Hawaii? And I'm saying, give answer without any additional text. And if I run with this prompt, so if I give this prompt to the language model, you see that it answers with Honolulu. And see, it added a period at the end, and this could trip up my downstream model if I'm only expecting the name of the city without any periods. So I could add, don't add any punctuation. And so we run this, and it says Honolulu without the period. Great. So it works for this small example. But imagine that now I have a model that does prompt engineering to extract information from a receipt. And that receipt looks something like the following: local market receipt. It has a date, it has a time, it has a cashier. It has items that I bought. Apples, Fuji, 2.5 pounds. I bought 2.5 pounds at $1.99 a pound, and so on and so forth. So a lot of information in here. And let's say that given the receipt below, I want the model to extract the items, total price, and format them as a tab delimited file. Don't give me any additional information. So check what it did here. I wanted to extract the items and the total price, and the items and the total price and their total price. So I'm going to run this and see I asked it for the items and the total price, not the price per unit. So this column is the price per unit, and it got confused. So it got me the item, the quantity, the item, the unit price, and the total price. What I wanted is just this one here and this one here. Additionally, it also provided me with this thing here, the header. That's not something that I wanted. So this prompt, has to be a lot more complex. Please remember not to include any header. So, okay, it removed the header. And now it listened and it's crafted that sort of result exactly like I wanted it. But it becomes a little bit more tricky because I have to do a lot of rewriting of my prompt to get it to do what it wants. And even then, it's not a guarantee that it's going to work if the model changes, or even that probability aspect of how the model runs can make it fail in the next run. A much better way to do it is by giving it examples. So remember the first time I said the simplest way to interact with the model is using this zero-shot prompting. And what I did earlier on is a zero-shot prompt in this case. But it turns out that it's much better to give the model an example of what you want the output to look like. And it's called few-shot prompting. So we're giving it a few examples before it takes a shot at solving the problem that we want to solve. So this helps the model understand the specific response criteria, and it's more effective for complex tasks. And trades tokens usage, it may increase the token usage slightly, but it becomes a little bit more accurate at doing its job. For example, oops, I have deleted this from here. So I'm going to take this and I'll say this as an example, right? No. Okay, sorry about that. So I'm going to give you an example with something a little bit more trivial, and we'll get to the example of the receipt in a second. So, for example, this is an example of a few-shot prompt. I say, question, what is the most populated city in California? And I give it the answer. Answer is Los Angeles. So I just gave it an example of what the question is going to be and what the expected answer is going to be. And I said, okay, question, what is the most populated city in Hawaii? And I prompted it with this answer format to sort of trick it to complete my sentence by just giving me the answer. And notice here that Los Angeles was not followed by a period. So it's going to try to mimic my previous example, my few-shot example, and give me the same thing. So if I run this example here, you see that it does Honolulu, and it does not include a period. So if I add a period here, you see that it's going to try to mimic it and add a period to it. So this is called a few-shot prompt. In this case, I didn't give it a few examples. I give it a single example. And even that very single example was very good at letting the model understand what we're trying to achieve and steering it to give me the answer that I want in a way that adheres to my requirements. So this can be applied to more complex formats. So I say receipt, right? And this is my receipt, the same as earlier on. And I say the output is ground beef, tab, \T for tab, new line, \TN, cheddar cheese block, tab, price, right? So I extracted these things here, and I showed the model the output in the way that I want to see it, which is right here. And now I ask it to do the same thing with this receipt that I give it here, and I provide an output section without any information. And it's going to do the same thing again, just like how it found the most populated city in the previous example. It's going to try to read this receipt here and mimic the output, and mimic generating an output in a format that follows what it has seen in the previous example. So if I do this, it's going to return this string here. And if I try to print this string, and you see that it's exactly the format that I wanted, it gives me the item. This is the name of the item, followed by a tab. The tab, we don't see it here, but it's actually a tab. The price, item, tab, price, item, tab, price. Exactly like we instructed the model to do. So typically, few-shot prompting is the most popular way and the most common way to write a prompt when you have a model that when you have a question that you want an answer for in a simple format. So the format could be a tab, could be a single word, could be a couple of words, but you want something that's straightforward and not too complex. Yes.
Writing out the I don't have.
So it mimics what you put it. It's going to think that you want to have that header, and it's going to give you the header back, right? So you wanted to show it. You want to give it an example. So, for example, if I'm explaining it to you, I say, hey, there's the receipt. I want you to give me this, this, and this. I'm explaining it to you. So really, like the way I think about it, I explain to a model what I want to see, as if it was someone who does not understand computer science, who does not understand programming, who does not understand formats. And I'm just explaining it to them by giving them example of exactly what I want to see, right? I'm giving it to a high school or a middle school student who's doing this job for me. I'm telling him, this is an example. This is what I want. If I give him the example and I show the header, maybe they're going to be confused and give me the header for the next one again, right? Yes. Yeah, no, you can remove that space. It's not really important. You can fix it in a way that makes sense to you. For example, I could remove that space here. I'm assuming that this is the space that you were referring to, right? Yeah. Okay. So, so the trick here, these are very, very simple example. I gave it one example of what I wanted the formats to be, and it did exactly like I instructed it, and I wanted the format to be, right? So it turns out that you can be very, very detailed in what the formats can be. For instance, imagine that we wanted to extract the items, but we wanted to also provide categories for these items. That's what you're going to do for the practical today. We're going to try to force it to give me categories of these items. Well, we can, yes. Oh, sorry. George.
Hello.
Oh, yes. Go ahead, please, Kevin.
Hi.
I
Yeah,
can't
thank
hear
you
what
for
you're saying.
running hybrid. I know it's challenging to see all the streams. It's going great so far. My question is basically, does negative examples, is that ever
No,
valuable? No.
no.
So,
You always want to give it positive examples. Negative
okay,
examples from experience rarely help because it does not know it's negative. It can be confusing and think
I
that it's
see.
something you want to provide.
Here's what I'm concerned about, right? Hallucinating, like putting the wrong price, and it looks right, right? Like I'm scanning dozens of these and it looks right, it actually puts the unit price, right? So that's what had my mind jump to. Here's a negative example of where you grab the per unit price. Don't do this, right? But you're saying it that causes more confusion than it solves.
Exactly.
Okay.
So what we're gonna get to is testing. Remember what I said earlier on? You want to do a lot of testing and benchmarking. And later on, I'm going to show you how to use a library to do testing. And you want to make sure that you do as many tests as possible to guarantee, at least in the test that you're doing, there's no examples of hallucination. I mean, it doesn't mean that it's not going to happen in real life,
Mhm.
but typically if you test on, I don't know, 30, 40 receipts and you haven't seen hallucination, it's a good telltale that your prompt is doing really well and you shouldn't be too worried about hallucination.
Okay. Awesome. Can't wait to see that stuff. Thanks.
Yes. Thanks for the question, Kevin. Okay, so for few shot prompting, the example that we gave here is very simple, but you want to keep examples as diverse as possible, and you want to make them relevant to your test cases. You want to use random order to avoid bias, and potentially even using dynamic selection for specific use cases. So this seems a little bit sort of abstract or maybe a little bit confusing, these explanations, because we haven't covered any sort of examples of complex few-shot prompts. We're going to see a few later on. But what I mean here by considering dynamic selection of specific use cases, so it could be, for example, that you want to assign labels or categories to items. and you have receipts from Best Buy, you have receipts from electronics, and you have receipts from a Safeway grocery store, and you have receipts from pharmacies, right? Medication. And the examples that you're going to put in your few shot prompts are going to make a difference, right? It's going to tell ChatGPT that if I see something like TV 80-inch or 88-inch, that's a TV, right? That's a electronics. But if I see something like broccoli, that's a grocery item, a vegetable, right? So it wouldn't make sense if I'm parsing receipts from Best Buy to include a grocery item. So I can, on the fly, decide to adjust this prompt and put items that are relevant to what I'm parsing. And that's the state of the art, is to build these prompts dynamically in order for them to make sense, in order for them to be relevant and be good examples to the model that you're using to extract this information. So I describe all of these here. I think it would make a lot more sense for you to read it after we completed this session and come back to it. It will make a little bit more sense. But I'm going to skip to a library that is the most common tool used for building prompts. This library called LangChain. So far, we've built prompts manually. But if you want to build something dynamically, like I said earlier on the fly put examples from categories that you think are more relevant, you want to use a tool that allows you to do all of this, and a tool that allows you to test these prompts and so on and so forth. It turns out that the de facto standard, the most commonly used for doing all of this, is a library called LangChain. LangChain has two words: lang for language models, and chain is a way to build chains or build pipelines of tools that allow you to achieve these objectives. So it's a modular framework for LLMs. Modular in the sense that I can combine pieces of code to do a lot of complex stuff. So LangChain does not only tackle built-in prompts, but allows me to build chatbots. It allows me to build generative question answers based on documents in databases and so on and so forth. It is, I think, the most popular and the most commonly used library, both in the private and public sector, in research as well. We've used it for a lot of different jobs, including, for example, parsing PDFs of research PDFs to extract meaningful interaction between a climate hazard and some species. Did you have your hand? Okay, sorry. Okay, so when we're working with LangChain, so LangChain has different components. As I said, these are the three most important components. The concept of a chain, which is, you can think of it as, for example, a pipeline. A chain is build this, then take this and give it to this model, then take this model output and give it as input to this model, then take the output of this model and give it as input to the next one. So you're taking the output of one program and passing it as an input to the next one. So that's what a chain is. It's just a pipeline of tools. It has support for most, if not all, big language models. So it's you can swap in one line of code without changing your overlying architecture or your overlying pipeline from, let's say, ChatGPT or GPT to Google Bard or Claude or any other model, right? And that makes it super cool because I don't have to use the library from ChatGPT like I used it earlier on, OpenAI. That constrained me, and that syntax and that output is specific to what OpenAI wanted their input and output to be. When using LangChain, I can swap in any model and it's going to work without any changes to the rest of the thing. It has this concept of agents. Agents are really popular these days. You can think of an agent as a small piece of software that knows how to do something really well. So, for example, you can have an agent that looks at emails and can do triage of emails and send an email to a nurse or send an email to a doctor or send an email to billing or send an email to, right? It does triage. The sole purpose of that agent is read an email and know whether it's a billing email or it's a scheduling an appointment email or a doctor email or a nurse email and so on and so forth, right? And this is sort of the future of language models. So they're all baked into LangChain. Has the concept of memory. So when you interact with a chatbot, you want your interactions in the past to be remembered so that the next question can refer to the old memory, and has text transformations. So we can work with PDFs, we can do prompts that interact with PDFs, and so on and so forth. So we're only going to focus on this first component, which is the chains aspect. We're going to build prompts and use them to extract information or to do something that fits a specific or adheres to a specific output requirements. So as I mentioned, we're going to stick to this, which is we're going to build a prompt using LangChain. We're going to pass a prompt to a model, and we're going to do that in the context of a chain. Remember, a chain is a pipeline, so we're going to build a prompt, or we're going to take the outputs of a prompt and pass it to a model as input. The way you do this is typically building a prompt using a template. So you have a template, and template is, maybe think of it as a reusable component that can be reused to customize various different prompts. We're going to see an example. You also have this concept of model. Remember, a model could be anything. Could be ChatGPT, could be Bard, could be Claude, could be Llama, could be Mistral, could be anything. And you have this operator, which is the pipe. And this is very common in computer science. We use this pipe to say we're building a chain or we're building a pipeline. So the thing that is on left of the pipe gets passed as inputs to the thing that is right side of the pipe. So how do we build a prompt in LangChain? So LangChain core has a module called prompts that has a class called prompt template. And so all we have to do, forget about this for now. We're not using this here. I'm going to move this to here instead. So all we have to do is provide a string that has the prompt text in it and pass this as input to this prompt template class and call the from template, and this gives me a prompt. So if I was to print this, it tells me that this is a prompt template. It has no input variables. There's nothing that changes in it. And the template is what is the most populated city in the state of Hawaii, provide city name and no additional information. That's the same prompt that I've used earlier on. So if I want to use this to pass it to ChatGPT, rather than do that complex gymnastics earlier on of, having to modify things and pass things on, what I'm going to do is I'm going to call a model. I'm going to build a model as simply chat OpenAI. And also LangChain has access to these different models, as I mentioned earlier on. They all have the same interface that I can query and format. So I build this model and I say, I'm going to build a chain that's essentially a prompt followed by a model. So the output of this prompt object gets input into a model. And now this chain can be invoked or can be called by giving it some parameters. In my case here, there's nothing that changes in this prompt. So input variables is empty. So I'm going to give it an empty dictionary. It takes as input a dictionary. So if I run this and print response, it shows an AI message, meaning the AI responded back to me. And the context of my message is Honolulu. So if I want just the answer, I do response.content, and I see that it's Honolulu. What's nice about this LangChain, it allows me to check a lot of other things at the same time, including my token consumption. Input token, so passing this message here got split into 28 tokens, and my output was 2 tokens. Why 2 tokens? Honolulu is only one word, but remember, it splits things into subwords potentially, and Honolulu in this case was split into 2 tokens. So I consumed 30 tokens in this query. Okay, so I can see my metadata and kept track of my metadata when I'm doing prompt engineering to see which prompt is giving me the right answer at the least amount, at the cost of the least amount of tokens possible. So just to give you an example, like we're parsing, I'm working with someone in the Department of Geography, and our token consumption estimated so far, my token consumption doing prompts, we're parsing PDFs, we're extracting hazards and how hazards affects species, how hazards affects crops, or how hazards affects edible species in general. So far, my consumption has been, or my cost for using the prompt to extract that data is about $2,600, and the estimated is about $6,000. So it can grow up very, very quickly when you're doing prompt engineering on massive data sets. And it's really important to know how many tokens you're consuming in and out of the model. Okay, so the great thing about this LangChain is it allows me to customize this prompt. So if I want to ask it this question in a sort of a programmatic way, and I don't want to keep changing the state in a new string, what I can say is provided a variable, right? And this is the same way we format variables in Python string, or if you're familiar with web programming, this is how you format variables in templates when you're printing stuff on the web. So we're saying that what is the most populated city in the state of state? This is a variable state. It's surrounded by these curly brackets. And I'm asking it provide the city name and no additional information. So I took the same prompt, but turned Hawaii into a variable. So now I can plug in any state I want. I'm not constrained to only working with Hawaii. I build my prompt template exactly the same way. But if I want to see what this prompt is going to look like, using, for example, state equals Hawaii, I can format it and see what it's look like. And see, on the fly, it dynamically formatted my prompt and it replaced this state value here with Hawaii. And now it says, what is the most populated city in the state of Hawaii? It turns out that we can do this dynamically when we're invoking the model, and we can send these variables when we're invoking the model. All I have to do is I do the same thing as before. I don't change anything. And I say chain.invoke, but now instead of passing it an empty dictionary, I pass it a dictionary with a key that is the name of the variable that I had in here, state, and I pass it the value for that variable that I wanted to replace. And it says chain.invoke, state is Hawaii, and you say that the content is Honolulu. I can say state is California, content is Los Angeles, chain is state is Georgia, content is Atlanta, right? And so it does this dynamically for me, and I don't have to customize it on the fly. So I want you to pay attention. Check what happened here. This could trip up my model. The dot or period is not included in first one, is not included in the previous one, which was Honolulu, but it is included in Atlanta. And that's what I said earlier on, that there are no guarantees this is going to work. Now, granted, I'm working with a model that's slightly older. So I'm working with GPT 3.5. By default, if you don't specify the model that you want to work with, it's going to default to GPT 3.5. So if I change this model to be, let's say, GPT-4 mini, which is substantially better than the old one. So I'm going to say model equals GPT-4o mini. And redo this. So it did Honolulu. And we're going to redo this. So now I can see that it's working with GPT-4o mini, the version that was released on July 18, 2024. And if I run this again, it's most likely going to give me the correct answer. So Honolulu without period, Los Angeles without period, and Atlanta without a period. So you see that these models, there are no guarantees, and you have to keep tests. So if I was writing a prompt from scratch, I would still need to implement, or using this programmatically, I would still need to implement the proper safeguards or guardrails to make sure that this is something that my model can take into consideration. We're going to see how to do it in a much, much better way in just a second. Yes. Okay, so Jerry, if you don't have tick token imported, just install it. Do pip install tick token, just like this, and it's going to install it for you. I'm sorry, I just realized that I had this version. I uploaded the version that didn't have anything installed. So if you have any issues post workshop, please just let me know, and I can work with you on installing and getting everything working correctly. So a much better way to do this, as I said, is using this few shot prompts. And one way to do it is doing this, what is the most populated, posing the question, giving it examples of what you want to see the input and the output. And here I say, state is Hawaii, city is Honolulu, state is California, city is Los Angeles, state is variable state, whatever I plug in there, and city is empty, and that's what it's going to complete for me. It's going to continue starting right here. It's going to try to continue starting right here for me. So I do the same thing. I pass this as a prompt template. I generate this template that takes this variable that can be updated on the fly. I create this chain by passing the prompt using the pipe into the model. And I invoke this chain by substituting on the fly at runtime when I'm executing this model, the variable state with the value Georgia. And if I print response.content, it's running. It says, oops, am I running the right thing? From string, prompt model, prompt model. Okay. Oops. Oh. Huh. That is super interesting. Check the response here. What is going on? It's using GPT Mini. Okay, this could be a good way to explain something else. Oh, sorry about that. My fault. Okay, so we're gonna redo this. I want to just provide this. State is Hawaii, city is Honolulu, California, Los Angeles, state is city, state, Hawaii, Honolulu, state, California, Los Angeles, state. Response is Atlanta. Let me just see here. So I want to show you one more thing here, which is that temperature component that I talked about earlier on. So let me recreate this model from scratch. Where is my model? I'm going back up right here. So recall that I mentioned Mini is one of the smallest model that you can work with. And Mini essentially can do a lot of mistakes because it's not as sophisticated as the GPT-4o. GPT-4o is a little bit more forgiving. Mini follows instructions to the dot and needs a little bit more tweaking when writing prompts. But it's a lot cheaper. So if you can get it to work on Mini, you save a lot of money when you're writing applications using when you're writing prompts for real life applications. So what happened here, if I create this model here and I run with this model here, check what's going to happen. It gets confused and it includes the response here, despite the fact that I clearly instructed it using this few shot prompting that I'm giving you state, city, state, city, state, city. And it's still being tricked. It's still not understanding what's going on. One thing that you can try to see if it's going to work is by changing this parameter called temperature. Temperature. I'm going to explain it in a second. So I'm going to set the temperature to 0. It doesn't do anything. I wonder whether it's using the right thing here. Oh. Yeah, it's still not, let's say 0.9. Oops. Sorry, doing stuff on the fly does not always give the expected results. Essentially, temperature is a parameter that varies typically between 0 and 1, and say typically because some of the models have messed that up and can go above 1 slightly. But temperature is how creative you want an answer to be. So, so if I take, for example, this model, and model has in LangChain, a model is its own thing and can be invoked by a string, and I say what is the capital of France, and I run, oops, temperature equals 1. And you see that the capital of France is Paris, but if I change this temperature to 0, it is, oh, it's giving me the same thing. It's not a good example here, but essentially the temperature is how creative it needs to be. Let's say something else. Let's try why is the sky blue? So if I give it this temperature 0, it tends to be a little bit more sort of mechanistic in its answer and a little bit more sort of deterministic in how the answer is going to be composed. If I give it a higher temperature, that means try to be a little bit more creative in your answers. So typically when you're doing prompting and you want an exact answer to something, you tend to set the temperature to 0, right? If you want to write something that is a little bit more creative, if you're writing text, if you're writing, I don't know, a poem, if you want some creative solution to a problem using code, you're going to set the temperature a little bit higher. So the other thing is that when you set the temperature to, let's say, 0, the answers are always the same. Whenever I run this model, I'll always get the same answer. Say answer in at most 15 words. Answer in at most 15 words. Oops, it wasn't the question. See, if I do the temperature 0, it's going to have the same answer. The sky appears blue due to early scattering of sunlight by atmospheric particles. And it's going to keep on saying the same thing over and over and over again. If I do a temperature of 1, which is the higher temperature, it's going to change this, and the answer may slightly be different from one run to, you see, it changed the last part of it, Earth's atmosphere, right? I run it again, it says atmospheric particles. So it is a little bit more creative, and the answers tends to differ. When you're parsing something, when you want a specific answer or a format in your answer, when you're prompting, you don't want that variability in answers. You want a consistent answer that's always the right one. And you want to set the temperature to 0. In this case, just working with a smaller model that was, getting tripped up by that sentence in the beginning. Hence the need for benchmarking and testing your solution before you deploy them. It turns out that what we've done so far was sort of the standard up until about a year and a half ago, when all the models started to push for a way to generate output in a JSON format. If you're not familiar with JSON, JSON is like a CSV or a TSV. It's a lightweight data interchange format. It's a way that we save data for interchanging or exchanging between computers and machines and so on and so forth. It's a flexible format, so it formats the data in a way that is readable. It allows me to nest the data in nested structures. And it's human readable, so I can open a JSON file and see what it looks like. And also is the de facto standard when you're working with functions, APIs, anything on the web, you're going to save things on and share things and use this JSON format. So JSON format looks something like the following. For example, it has this dictionary-like structure. I'm going to say person, name is person, or I'm going to say, let's say first name is Mari. I can't even spell my name. And I'm going to say, for example, job, right? This job could be a nested structure itself. So title is researcher, let's say, and years at position, I'm going to say, let's say 20, right? So you see that it's readable. It has this dictionary-like structure where it has keyword, value, keyword, value, keyword, value, and so on and so forth. So it turns out that the vast majority of language models these days understand JSON and have somehow been tweaked to be able to generate JSON format accurately. We're going to try to generate this JSON format without doing any of this gymnastic. Or maybe, is this a good time to take a break? Yeah. So we're going to take 5 minutes break, or 5 minutes break, and I'll continue it right after that. If you have any questions. One, I think maybe we can hold off on answering this question until the end. I think it looks a little bit more, it requires a little bit more conversation. Fantastic. Okay, so I'm going to skip a little bit of detail just because this is going a little bit slower than I had expected. But essentially, the best way to format outputs in a way that programmatically makes sense is using Pydantic. If you're not familiar with Pydantic, Pydantic is a class that is commonly used to write data types in Python. So it's used a lot in data validation or type annotations. I'm going to give an example in a second. Pydantic is also very commonly used for working with API interfaces. If you want to call something on the web, call, I don't know, a service to get a temperature, or call a service to reserve a ticket for a destination. So you're going to validate that information, both the input and the output, using this library called Pydantic. This is what a Pydantic class looks like. So I created a new type called person. It is of type base model. So it's a model that is the foundational model in Pydantic is called the base model. And I'm building on top of it. And I say this model has a first name that is a string, a collection of characters, a last name that's also a string, and an age that is an integer that is 20 by default, right? So I'm giving it a value by default. And I can write something like the following: person, first name is John, last name is Doe, and age is 22. And this creates this new object that is of type person that I just defined here that has these three characteristics. So here's an example. If I print this, you can see that it created this object that has fields called first name, last name, and age. And I can access them using the dot notation in Python and do something like p.lastname, and it gives me Doe, or p.age, and it returns 22, and so on and so forth. So forget about this. I'm going to skip this for now. So if I was to build, these are all three required fields. If I was to do something like the following and skip this, it would give me an error. It would say, hey, you're missing a field. You're missing a field that is required, that is first name here. So it knows how to validate these things for me. And that's super useful because this can be used in conjunction with language models and with conjunction with ChatGPT, with the LangChain, to format what the output is going to be like and what we expect the output to be like. I don't need to go into the details, but these objects of type Pydantic can also implement some specific validation. So you can validate that fields when you're creating them have certain characteristics. For example, I can say that field validator age is the field as V has to be between 1 and 140. Otherwise, raise an error saying the field is invalid. And if I run this field that has 222, it says got one error, validation error for person. If I change it to 98, now it works and it returns the object of with three fields, age, first name, and last name. Okay, so it turns out, as I said, that these objects are ideal to define what we expect the output is like. So I want the output to have a first name, a last name, and an age. The first name is a string, the last name is a string, and the age is an int. And there is a trick to take this and transform it into instructions that we can pass on to our model without really having to do any additional work. And the way you do that is by passing this field called format instructions. So here's an example. I'm going to go back to my city. I'm going to define city because I want city, like the most populated city. And I'm going to define this base model, and I'm going to include descriptions in the documentation of this class. I'm going to say this object holds information about the most populated city in a given state. This field is of type string. It's a field, and it's the name of the most populous or populated city. And I'm going to create a pydantic output parser, and I'm going to call it city parser. It turns out that this city parser has a method that's called format instructions. And if I print it, it generates instructions that we can hook into or we can pass into our prompts so the language model knows what to do. And a language model prefers much more to see something like that looks like the following than a description in plain text, because models understand this JSON structure. So my model understands that I want to generate an object that holds information about the most populated city in a given state. I want the model to have, or I want this object to have a city field, the description of which is the name of the most populated city, right? And I want the city to be required. So don't give me an output that doesn't have this field that is called city. So all we have to do is modify our prompt. So the previous prompt that we had was, what is the most populated city in state? This was a variable. We're going to add another variable called format instructions. And this format instructions is where we're going to inject this chunk of text that was automatically generated. So in addition to sending our prompts, we're going to send in instructions for the model to follow when generating the outputs. So this is what the prompt looks like. It looks like the following. This is dynamically loaded, but so is this, dynamically loaded. Now, when we build this prompt template, we're going to build it using the prefix, which is this part here. And we're going to say that we have two variables, one that is an input variable that changes during the input. The user is going to give it to me. That is the state, which is this part here. And one that is partial. Partial means you can fill it up now if you need to, and that's the format instructions. You fill it up using this city parser.get format instructions. So run this method, generate the output, and plug the output in this variable here right away for me. So if I was to format what the prompt looks like, just to look at what is going to be sent to the model, and let's say that I have my data is oops, it's not defined, but let's say data is a dictionary that has states and Georgia. Let's say Georgia. And so if I was to, what is the most populated city in Georgia? I'm giving it to this data here. So it automatically formatted using the state, and it added, or it replaced this format instruction by this long prompt that describes exactly what we want in terms of format, right? So now I create my prompt chain the same way, pass the prompt into the model, and invoke the chain using the data. And check this out. What it did is generated a JSON object that has the following format that I need. It has exactly what I need from it. And so if I pass it into my city parser, this was Utah. I didn't run this. You see that city parser has a city that's called Atlanta, and I can call it parser output.city, and it returns the value Atlanta for me. So it returned the object as JSON exactly as I asked it to return it. And this object JSON, let me print it so you can see what it looks like as opposed to a string. It's a JSON object, and it has this city as a key and Atlanta as a field. So let's do it another example. So here what I'm going to do is I'm going to give it an utterance. I'm going to give it something that the user said. For example, the user is going to say, hey, I'm John from New York City who loves tennis. Or I'm Maddie from Honolulu and my favorite sport is tennis. And what I want to do is I want to extract the field from that utterance that are the name of the person, as it was said, the hobby of that person, tennis in this case, or surf, and the location of where that person lives. What I'm doing is I'm setting the name as required. So this ... in Pydantic means that it's required. And if you remove the dots, you can say none, and you can say optional, and it makes this hobby and location optional. So the person may or may not say their hobby and their location, and this still would be extracted. I do the rest exactly the same way. I'm going to build a pydantic output extractor, and I'm going to generate this blob of text that I'm going to pass on to my prompt as I'm sending it to my language model. So the prompt is the same. I changed what the task is, and I say the person said something below about themselves. Please parse only the fields of interest. Those are name, preferred activity, and location. And I'm going to say what the person said, which is the utterance that I'm going to pass it, and the format instructions, how I want the instruction, the output to be formatted. So, for example, if I say something like the following, there's an error here. State. It's still taking the front templates. What person said? Oh, did I run all of this? Person details, this. There you go. It says the person said something below about themselves. Please parse only the fields of interest, blah, blah, blah. And the person say, hi, I'm John. And I am replacing that blob of instruction using that thing that was generated automatically using Pydantic object that I created. So it knows that I want this object to hold information about a person, including the preferred activity, name and location, city. The properties are name. The properties are the name, which is the name of the person. The preferred activity can be null. The default is null if I don't provide an activity. And the hobby is also null if I don't provide an activity. So same thing again, I prompt into a model to generate a chain, and I invoke my chain using this. What the person said is, hi, my name is John, I live in Honolulu, and I like surfing. And if I run this, you see that it parsed it automatically for me. And it grabbed the name John, surfing, and Honolulu as the location. I can change this on the fly, and we run this. And I am a huge fan of snowboarding. Of course, because that's what we do in Hawaii, right? Right. And so it grabbed the hobby as snowboarding. It grabbed the city as Honolulu, as city in Boulder, and run it. It grabs the information as Boulder, snowboarding, and John. So think of the implications of this. We write a prompt simply by defining what the object is. So imagine you're parsing a medical electronic health record, and it has a first name and a last name and a disease and a disease description and the medications. All you have to do is define this object that describes what those fields are, the EHR, electronic health records, the name of the patient, the disease, the assessment, the treatment, and so on and so forth as descriptions, and add these definitions of what these fields are. And LangChain does all the job behind the scene of coaxing the model to format the output so that you can grab the outputs from that text on the fly. Cool. So zero effort to do something that would have liked, if you were to write a prompt, you'd say, hey, grab this information and make sure the name is this, make sure the last name is this, make sure the disease is a number, or make sure the age is a number, and so on and so forth. And it puts a lot of effort into validation at the end. So the novel approach to prompting with ChatGPT 4.0, there is yet a much more sophisticated way. Just because GPT-4, and not all languages support this, has been trained to guarantee that the objects that are generated are going to follow this. So this approach in us coaxing the model by giving it this chunk of text here still tries to just be convincing to the model, explain to the model what it should do, and 95% of the time it's going to do it right. And if it doesn't, the parsing is going to yield an error, and you can say, if there's an error, send it back to the model and say, hey, this error happened, age was not a number, try again. And you can say, repeat it 3 times or 4 times or 5 times, as many times as you want. ChatGPT 4.0, the most recent version, guarantees that if you call it this way with structured output and pass it this pedantic class, it is gonna absolutely generate something that follows the standard that you wrote in there. So you could do prompt engineering. Everything that we've done so far can be replaced simply by these 3 lines of code. I take the model, I tag along this with structured outputs and give it an object. And this object could be a complex object, right? It could be, for example, an EHR that has 50 fields in it, and every field has specific values. For example, I could have said that gender could only be one of 4 possible values, and it's a single letter, right? I could implement that and validate that, and ChatGPT would make sure that it never gives me anything that is not one of those possible values. If I'm parsing, for example, what the user asked, hey, get me an airline ticket. I want to fly only through United or Hawaiian Airlines. And if my object was written such that that carrier is only a set of possible values, it would never give me something else beyond that set of possible values, right? So the power of knowing Pydantic when you're prompt engineering exceeds you being able to write an eloquent prompt, a kind prompt, a clear prompt, just do it in an object and pass that object instead. It will perform a lot better than if you had to write that prompt from scratch. Okay, so here's the example. We're going to build this prompt. It has this variable. It's the same prompt that I did earlier on, what person said, and the template for this prompt. So I can put all of these in a single line, parse user information from the utterance below, and I say what person said. I removed format instructions. I don't care about that anymore. All I need to do is tell it what is that variable that will need to be updated on the fly when I run the model. I attach or bind or tell my model to act in accordance to this person details and put the results in this structured LLM. And I build my chain the same way. Prompt, pass it to structured LLM, which is the LLM that I built here. And I invoke it the same way. I say what person said, and it will always guarantee that would respond using this person detail format that I have. So what I just did in the past hour and a half is give you sort of the historical evolution of how we've been prompting. And you can see that this 5 lines of code surpasses by far everything that I've described so far. Because there are theoretical guarantees, the model has been trained to follow instructions and generate something that looks like the following. So prompt engineering went from being able to write these very complex, sophisticated prompts that describe exactly what we want to being able to write code and training models to mimic what that code represents structurally, which makes it substantially easier. And notice that here, for example, location, I've never said my location. I'm John and I like soccer. Or I am John and I'm John, right? And both of them are going to be none because I've never specified my hobby or my location. So this is super, super cool. And as I said, prompt engineering is typically for writing prompts to follow instructions and give you something in a format that you want specifically. Well, that's exactly what we're doing, right? Using this. So now the question is, how can we test and evaluate our LLMs? Again, LangChain, among many, many, many other things, has a framework called Evaluate. And that framework Evaluate allows us to compare a response from a language model to some reference and tell whether that's acceptable or unacceptable. Turns out that we can compare things that are generated by LLM to a reference in many different ways. For example, if I say, what is the capital of France? The only valid answer is Paris. And if it says something like, the capital of France is Paris, well, maybe that's okay. Maybe I don't mind that it says something like that. So how to compare the capital of France of Paris and Paris? Is the answer correct or not? Well, what I can do is search for the occurrence of the word Paris in the response. And if it occurs in the response, I'm going to say, yes, that's a valid answer. Or if it says Paris without anything else, that's also valid. So there's different ways that we can compare a generated outcome from a language model and the actual reference that I consider as a correct answer for my model. So So here is where I summarize these things. I can say I want the answer to match exactly this correct answer. And in this case, I want perfect string comparison to evaluate if two strings are completely identical or not identical. So I only want the answer to be Paris. I don't want it to be Paris period, or I don't want it to be Paris with a lowercase p, or the capital of France is Paris. I want it to be Paris. And a prompt has to generate that exact thing. I'm going to talk about the regex match. So a regular expression essentially looks for partial matches. Like I said earlier on, if the true answer is Paris, but I don't mind if the model says the capital of France is Paris, right? It gives me the long answer. What I want to do is build a regular expression, sort of a partial match that allows me to look for the occurrence of Paris in the answer. If a valid answer, for example, to a summation, like I bought $20 worth of clothes and $15 worth of accessories, what is the total amount that I spent at the store? And I wanted to generate 35, right? 20 and 15. And 35 is the correct answer, but it generated, the answer is, or the total amount that you spent is 35. Again, it's a partial match. So that's when we use regular expressions. It could also do a string distance. String distance is how far are these two answers apart? How many characters are different between them? For example, if I do Paris with a period, or Paris exclamation point with the reference is just Paris without any punctuation, that's still valid. It's not an answer. It's not a big difference. There's only one character different between them, which is the punctuation at the end. That's a string distance. So you could say the answer that the model gives me compared to the true ground truth answer is one character or two characters or three characters apart. That's fine, right? But I don't want anything that is above 3 characters considered an error. The other most commonly used things, particularly when you're working with complex models or things that use chatbots, is you have an answer that is true. You know the answer is true, but there's different ways to formulate that same answer. For example, what are 3 different ways that I can cook eggplants? And I want, just give me 3 titles of recipes that I can use to cook eggplants. And it could give you 3 recipes, right? And so that concept of the answer could be different how you call that model. Maybe your ground truth is eggplant fried eggplants, or barbecued eggplants, or eggplants in an oven roasted, right? But the model said eggplant roasted first, and the next one was baked eggplant, and the third one. So you want to know how similar conceptually those things are. And that's when you use something called embedding distance. And embedding distance and embedding essentially is just a numerical point in space sort of vector representation of an item. And you compare these 2 vector representations to say how similar are they numerically to each other or not. We're not too concerned about it here. For everything typically that you do when prompt engineering, you're either going to look for an exact match, a regular match, regular expression match, or a string match. I'm going to give you an example here. So LangChain, again, as I said, has this submodule called evaluation, which has a method called load evaluator. This is how we load ways to evaluate methods. And I'm going to say load evaluator that is an exact match. And this evaluator here then can be used by evaluating strings. So, and it's exact match, meaning that I'm looking for an absolute exact match between them. And I say, evaluate this first string, evaluates the cat sat on the mat as the prediction of the model. And the reference was the cat sat on the mat. And it says that the score is 1 because they're absolutely the same. So let's change this and say the cat was sitting on the mat. And you say that the score is 0, so it's either 0 or 1. Exact match is either 0 or 1. So what you have is also this concept of embedding distance that I referred to. And embedding distance kind of sort of compare concepts that are not exactly the same, but it shows you how conceptually similar they are. So if I compare, and though it says here the score, it's not a score, it's actually a distance. Distance ranges between 0 and 1. A distance of 0 means they're identical. And a distance of 1 means they're far away from each other and they're not the same. The concepts are not the same. So if I do something like the cat sat on the mat and I use the embedding distance, so I need a model to compute those embeddings, those numerical representation of the prediction and the reference. And I compare these two. It tells me that the score is minus 4.44, E minus 16. So 0.000000, a bunch of zeros and a 4. So it's essentially a 0. So it's a distance of 0 between them. That means that these two answers are identical, right? If I change it slightly and it says the cat sat on the mat and the feline rested on the rug, they're still very similar, right? A feline is a cat and a mat could be a rug. So you see that the score, although not identical, is very close to 0, 0.07. If I change it to, for example, the cat sat on the mat and the reference was the kid went to school and he had pizza for lunch, you see that the distance is substantially higher. The problem with this is that, well, you know, what is high, what is not high? You have to really do a lot of manual check-in to see what high is. So this is 0.07 was something that's slightly similar, but 0.18 was something that's substantially dissimilar. So you have to manually check and yourself set what the threshold are reasonable for your examples. So I'm going to show you all these examples using, for example, this here does exact match. So what is the capital of country? Reply with just one name. So this is my prompt that I want to test. The variable that I'm going to pass it is this country here that I'm going to format on the fly. And I'm going to build some test cases. Every test case is going to have the country and its true correct answer. The reference answer is Paris. For Japan, the answer is Tokyo. For Brazil, the reference is Brasilia. And I want to evaluate this prompt that I created here based on this exact match. So if I run this, it's going to run and it's going to show me that for France, check mark, I got Paris. Japan, the model got the right answer, Tokyo, and checkmark got Brasilia. And here I was doing the exact match to make sure that the match is perfectly identical between the two use cases. So I can test all of them using, for example, what is the main use of an object given, give a short answer. So here an object could be, for example, an umbrella, right? And the short answer is to protect from rain. And I want to use a model to see whether it's going to give me something that makes sense and is able to explain in a very short sentence what the objective of this object is, like an umbrella. And if I run this, what I'm doing is I'm calling all of the models that I explained earlier on, the exact match, the string distance, the regular match, and the embedding distance. And you see how these things work. So I'm testing, my test is umbrella. The model says the main use of umbrella is to protect against the rain or sun. And the reference was to protect from rain. So exact match was 0. The distance was 0.42. So again, regular expression match was 0. And the embedding distance was 0.1. So fairly close in this context. The embedding distance is going to get bigger and bigger as the sentence also gets larger and longer and bigger. So I think with that, I've covered pretty much everything that I wanted to touch upon. I've included some other concepts that you may be interested to look at, namely something called the chain of thought when prompting. And essentially, chain of thought just prompts a model to think in actions, in steps. So, for example, think step by step. And something else that's called react, reason, and then act. So it is the same thing as chain of thought. So it thinks steps by step, but it has access to a set of tools. For every step, it can decide to validate or to run a tool to make sure that it has data to move on to the next step. These are not very complex or sophisticated. They're not as used these days because the models have gotten so sophisticated. In fact, this chain of thought is embedded in ChatGPT 01. So that's what it does behind the scene. It does chain of thought. So you don't even have to use chain of thoughts anymore. If you want to use chain of thought, just use 01. It does it a lot better. Some thoughts about, as I said, when you're writing these prompts, you have to be concise. You have to make sure that you don't spend a ton of money when you can save money. So be concise and make sure that your prompts as short as possible. So the way to do this is typically not to try to be overzealous before a problem arises, or think about all the problems that can arise and implement them. Don't do that. Start with the minimal, smallest, shortest, more concise prompt that you can find, and then see where it breaks, and then add that exception to the prompt, either by specifying it Pydantic, adding the description in Pydantic, or rewriting your prompt, or giving examples in your prompt as you see fit. So Pydantic, as I mentioned earlier on, can also have examples baked into it so that it passes the model, it passes that Pydantic base model, but also the examples at the same time, without you having to specify those examples. Yeah, if you have any questions, I'm happy to answer any questions now, but also if you have any questions as you look at this notebook, or as you start practicing with it, please do not hesitate to reach out. I'm always happy to answer any questions that pertain to what we've covered. That's it. Yes.